Alright, so we're going to take a look at finding the equation of a tangent line and the equation of a normal line to a curve. So first, a couple definitions. So in blue here, you see I've drawn the function f of x. We have a point of interest, which I am referring to as x sub 1, y sub 1. Our tangent line, of course, is going through and just grazing the curve, just hitting it in one spot. Well, we've seen that. Well, now we have our normal line. So by definition, a normal line is a line that is perpendicular to our tangent line. So you can see that there is a right angle here where they meet. So if they are perpendicular to one another, it means they're going to have opposite reciprocal slopes. So we've been looking at how to find the slope of a tangent line. What we're going to focus on now is writing the actual equation of that line. And if you recall, in chapter 1 we had a video on writing equations for lines. So we're going to end up using our point slope formula to write the equation of both the tangent line and the normal line. So let's take a look at an example. Alright, so in this example we are looking to write the equation. So we're not just interested in the slope, but we want the actual equation. So make sure you underline or box in that word. We want to do this for the tangent line and the normal line to the curve. Our function is 4 minus x squared, so you should know what that looks like. And our point of interest is when x is 1. So what we're looking to do here is draw in, I'm going to just sketch here our tangent line. You can see that the y-intercept there is something bigger than 4, so that would be my tangent, and then my normal line would come through and hit it in a perpendicular manner, so we'd have a right angle. So you can see that has a different y-intercept. So we're looking to come up with, so I'll just put a t here for tangent and then an n for my normal. So we're looking to write the equation for those two lines. So we'll start with the equation for the tangent. Well, recall we need, since we have a point here, we're going to want to use our point slope formula. We know how to find the slope, and we are essentially given a point. Well, let's find the complete point. Let's find the y value that goes with it. So in other words, let's find f of 1. Well, that's not hard to do. We're just going to put 1 into the function, and we're going to get 3. So our point of interest is 1 comma 3. That's our point of tangency. So let's set up our point slope formula. So recall, this is where we have the 3 boxes to fill in. So the y value goes in that box. The x value goes in the last one. So in this box we need our slope, and we're going to first find the slope of the tangent. So here was our equation. So to find the slope of the tangent, sure, you can go through that formal definition or that difference quotient like we talked about, but I know you're itching to just use the power rule, if you recall that from last year, and that's coming up very shortly. But recall that the derivative of 4 would just be 0, and then if you apply your power rule on negative x squared, you would get a negative 2x. If you remember that from last year, awesome, go ahead and use it here. If not, you could just go through the steps of using the difference quotient like we talked about earlier. So that's our formula for finding the slope of the tangent. If we want to find the slope of the tangent at x equals 1, well, this would be negative 2 times 1, so the slope of our tangent would be negative 2, so that's going to go in that box. Sometimes people have a tendency of wanting to put this negative 2x in that middle box. You're never going to put something with an x in there. Don't forget to plug in the x value of interest from the problem. Well, from there we can clean this up. So when we clean this up, we end up with y equals negative 2x plus 5. which if we look at our graph, that seems to make sense. The y-intercept is plus 5. It's definitely greater than the 4 from where the parabola maxes out, and the slope is negative 2. Alright, so now let's find the equation of our normal line. Alright, so first I want to address a very common mistake. So if we're talking about the equation of the normal line, people know to take the opposite reciprocal slope. They know the slope is going to be 1/2. Well, the biggest mistake that people will make is they will keep the y-intercept the same. You can see from our picture here that that normal line does not have the same y-intercept. So what you need to do is go back to your original set of boxes, alright, and drop in your values. This is still going to be 3, and this is still going to be 1, and then this is where we're going to drop in our 1/2. So let's clean this up. So when we distribute our 1/2 and then add over a 3, you end up with 2.5, which we can express as 5/2 for the y-intercept. So this would be the equation for our normal line. Again, 2.5 is your y-intercept, which, looking at the graph, certainly appears more reasonable. Okay?